Okay, so now we are going to take a look at another example, and this example is kind of a little, now this is not like any other example that we did earlier. So let's take a look at this. So we need to discuss the continuity of the function f defined by f of x is equal to x plus 2 if x is smaller or equal to 1, and x minus 2 if x is greater than 1. Okay, so this is the given function. Now we need to discuss the continuity of the given function. Okay, so the first step, when you look at the given function, you say, okay, the function is defined for x smaller than 1 and x greater than 1. What about x is equal to 1? So the thing that we need to do is now check the continuity at x is equal to 1. Now the first step is finding the function f of 1. Put the value of 1. That'll be equal to how much? Now for x equal to 1, smaller or equal to 1, the value is x plus 2. So it'll be x plus 2, that'll be equal to how much? 1 plus 2, that is 3, right? So the value of f of 1 is 3. Okay, the second thing that you need to do is find the LHL, the left hand limit. Okay, so we find the LHL. Now how do we find the LHL? We put limit x tends to 1 minus, right? Because we are checking the continuity at 1, and when we say left hand limit, we're talking about the values of which is, suppose this is a 0, then we're talking about values on the line. I mean whatever the line by which the function is defined, we're talking about, when we say left hand limit, it's those values on this line to the left of 0, right? You remember that, right? Yeah, so I'll take that out. Yeah, so limit x tends to 1 minus of f of x. And now for when x smaller than 1, because negative, it should be smaller than 1, so the value is x plus 2. So you put limit x tends to 1 minus of x plus 2, which is again equal to 3, right? Now checking for the RHL, the third step is checking the RHL. So RHL will be limit x tends to 1 plus, because in this case we're talking about the value which is to the right hand side of the 0 in the graph, right? So we put 1 plus of f of x. Now we have for x greater than 1, 1 plus greater than 1, the value is defined by x minus 2. So we can write this as limit x tends to 1 plus of x minus 2. Now put the value of 1 here, then you'll get 1 minus 2 is equal to negative 1. Now we have the value of f of 1 LHL and the RHL. Now we know that for a given function to be continuous, what is the rule? The LHL should be equal to the RHL should be equal to f of a. Now in this particular case, f of a is given by this value, which is equal to 3, and LHL is also equal to 3, but RHL is equal to -1. So we can clearly say that LHL is not equal to RHL, which is not equal to f of a. Therefore, the given function is discontinuous at x is equal to 1. Okay, so if we actually want to draw the graph of this particular function, then let me just clear this for you. Right, yeah. So if we want to draw the graph of this given function, we need to draw it like this. I'm really bad at drawing graphs, so right, so here we have the x-axis, and here we have the that's kind of a little big arrow. Yeah, we have the y-axis. And now if you want to draw the graph of the given function, then we need to, you know, the point will be here, right? The point will be here. It will actually be something like this. So the value, this will be -1, this will be -2, and this will be what? This will be what? This will be what? -3. Sorry, I was looking at some other place. It doesn't mean I didn't know what was coming next. Yeah, you can get that right. 2, 3, right? That doesn't seem like 3. Now, the graph will be something like this. It'll go here. It'll pass through this point, and the other one will pass through this point, and it'll go something like this. 1, -1, and this point will be 1 and 3. So this will be the graph of the given function, right? So totally, since the left and the right hand limits of f at x is equal to 1 do not coincide, so f is not continuous at x is equal to 1, right? And hence x is equal to 1 is the only point of discontinuity of x, right? All the other points are defined because you know that for x smaller than 1 it is x plus 2, and for x greater than 1 it's x minus 2. So basically for all the other points x is defined, but it is not defined at x is equal to 1. So this is the only point of discontinuity in the entire function.